Welcome back. We're in Algebra 1. We're looking in the unit on solving equations and inequalities, and this problem set is titled Number of Solutions to Equations. So they ask questions like this. How many solutions does the following equation have? Here's the equation. Now, in the past, you've had equations mostly that have one solution, so you're pretty used to there being one solution to an equation. But that's not always the case. Sometimes there are no solutions, sometimes there is exactly one solution, and sometimes there are an infinite number of solutions. So let's see what happens with this. If we solve for y, like you would normally, what will result is an equation that says y equals a number. If that's the case, that is the one solution. But if you get an equation that doesn't say y equals a number, then that means it either has an infinite number of solutions or no solutions. So let's see what happens. All right, so we'll simplify the left side a little bit by using the distributive property. So negative 17 times y, and negative 17 times negative 2 is positive 34. And on the right side we have negative 17y plus 64. So here's our somewhat simplified equation. So I want all my y's on the same side of the equation, so I'm going to add 17y to both sides. If I add 17y to negative 17y, that's 0. So this side of the equation says 64. If I add 17y to negative 17y, that's also 0. The only thing left on the left side of the equation is 34. So the result, I did an appropriate thing. I did the same thing to both sides of my equation. So if this equation has a solution or has any number of solutions, I will have gotten to the solution by the end. But this says 34 equals 64. Well, that's not true. And it doesn't matter what you say y is, because the y's all canceled out. There were no y's left. So you could make that y be 10, there'd be negative 170 here, there'd be negative 170 there. Those would cancel from both sides of the equation, and you'd be left with 34 equals 64. It's not true. It's never true. And so there are no solutions. So let's see what happens there. What happened in order to get no solution? The variable had to cancel, had to totally disappear from your equation, and you were left with numbers, only numbers, and an equation that's false. If y doesn't matter and the equation that results is false, there's no solution. All right. Next question. And this one says, how many solutions does the following equation have? Same question, different equation. So let's look at what happens. We'll distribute negative 14. Negative 14z, and then negative 14 times negative 5 is positive 70, and on the right side I've got negative 14z and positive 70. You'll notice I have the same number of z's on both sides of the equation. That means when I add that number of z's to both sides, they will disappear, they will cancel away, and I'll be left with 70 equals 70. Okay, so it doesn't matter what z is, the equation simplifies to 70 equals 70, and that equation is true. So I could put any number in for z, and I'd get a true result. That means that I have an infinite number of solutions. It could be 2, it could be negative 5, it could be 70,000. Any solution, any value or number for z is going to give you a correct answer. So every number is a solution. It has an infinite number of solutions. All right, next question. This asks, how many solutions does the following equation have? We've got negative 2z plus 10 plus 7z. So we want to combine like terms here. That's 7z minus 2z is 5z plus 10. the left side of my equation. 16z plus 7 is on the right side. Notice I have a different number of z's on both sides of the equation. That means when I subtract 5z, I will end up with some number of z's over here. That's actually enough information for me to know that this has exactly one solution, because in the end I'm going to have z on one side of the equation and a number on the other side. So I can select exactly one solution. They didn't ask me what the solution was to that equation, they just asked how many there are. So I can answer that. And go to the next one. How many solutions does the following equation have? Okay, so we have negative 7x minus 15x, that's negative 22x. We have negative 22x on the left side of the equation. We also have negative 22x on the right side of the equation. That means when I add 22x to both sides, the x's disappear. So I don't have only one solution because it doesn't matter what x is. Now, if all the x's disappear, I'm left with negative 10 equals 83. And that equation is false. It is not true, and it doesn't matter what x you put in there, so it has no solutions. There's never a case where negative 10 equals 83. And we're done.